There we are. So we have diagnostic information here, but we can also get a 3D view of what the HoloLens actually sees. So this is the point cloud or rather mesh that it's creating in real time. As you can see, that's the room we're standing in. There's the table. That's the point of view of the HoloLens in real time, first person view. There is a bit of a delay. The HoloLens does not need a cable of any sort, it's all on board. This is just to give the preview, otherwise it's really laggy over Wi-Fi.
Point it at me, let's have a look at what I look like with this.
So, can you be seen? Because it might, because you're effectively a dynamic mesh, it might not be tracking you. Are you actually showing up?
Some things there.
Maybe let's see if I update it and give it a... Oh, is there a...
Yeah, something is there.
Okay.
Definitely.
Yep, and that is enough information for the HoloLens to say, right, there's some sort of object
I
there.
can sort of see my camera there,
Yep.
holding point, so I'm pointing at the laptop obviously, which is on the table.
Alright.
Yeah.
Do we ever... Hold on, let's...
Try and stay still.
Okay, and I'll just tell it to update the mesh. There we are.
So is this is basically a depth map of me, is it?
Pretty much, yeah. Well, from this angle only.
Yeah.
I have to walk around otherwise.
I'm seeing some blinking red lights on you.
That is the depth camera array that's on the top of the HoloLens. Very similar to a Kinect, so the exact cocktail of sensors is not very well known.
Talking to you now, I can sort of just about see your eyes, but it feels a bit like I've walked into the future here.
Indeed, it is. Of all the various head mounts we have, this one is probably the more Star Trek-y of the lot. Yeah. Just like the Kinect or the Tango and all those devices, what it's doing is reading the environment around it, which is different from what, say, normal optical AR does. And by creating a mesh, it's understanding the environment around it, and we can start placing content there. So, as you can see, that's the example of of what it's seeing, the mesh it's creating in real time.
Is it constantly updating that?
All the time. It's reading the environment all the time. And now this is a view exactly what I see. So, I can populate the world around me with any virtual content I want. So, this is the menu, basically. You should be able to see it. There we are. So that is a hologram in space. Let's go place some other stuff. For example, my settings. I can either place it in space, just leave it there, or I can go find a nice flat surface like, say, the side of this printer and place it. And that is now locked there. That's where it belongs. So that is now normal Windows 10 menu. Many of you will probably have seen it before. There we are. Or we can start placing other stuff. Let's place it's a theme we put around felines for these demos usually. So that is now locked onto the table. It won't hover, it won't move, it is there. Now, the key thing here, unlike most of the other AR solutions we have seen, is seeing as these sensors have an understanding of depth, they can deal with the occlusion problem. So the occlusion problem is where any AR solution doesn't exactly know what it's looking at. Now, and in which case it draws the digital content above everything. So if you've used any AR, any mobile phone-based AR with a marker, you have probably tried putting your hand in front of the marker, see if it occludes the virtual content, or everybody tries to go pick stuff up. Normally, with marker-based AR, that simply won't work. All it can really do is tie content to that marker. But in this case, it does have a sense of depth, so it can effectively read your hand and stop drawing content over it. So if I put my hand over the cat, right, you can see now it is not working because it hasn't triggered for my hand just yet, but it will eventually catch on.
If you went kind of looked behind this laptop, would the cat disappear behind the laptop?
It should, assuming the device has actually read the laptop. Let's have a go. Oh, that is stuck.
Does the stickiness happen quite often, or is it?
No, it's only for the preview, really.
Oh, so basically it's because we're looking at it on the laptop.
Indeed, it's a bit of a debug view. As far as my experience goes on the HoloLens, everything is smooth. Oh, there we are. So let's have a look. Sadly, we don't have a lot of occlusions here. No, my laptop doesn't seem to want to hide it. The problem with the room here is there's not a lot of stuff to hide behind. So let's try something else. If I was to take another hologram and place it behind something like, say, on the floor over here, right? There we are, I can see the dog, and now, table's in the way, can't see it.
Yeah, okay.
Yep, so this is a case where the geometry has been correctly read, so the HoloLens is sure that that is a static feature in my environment. So it now has built geometry, as we saw before. Actually, we can switch back to the previous view. There we are. So this is the geometry that it is using for the occlusion.
Oh, so you can see that table there.
Yep.
It's not perfectly smooth.
Exactly. So previously, the cat could not be hidden behind the laptop, because as you can see, the laptop's shown up as a short mesh. If I had kept moving, it probably would have hidden it. The table, though, is a nice solid object. It's got that. And the dog is hiding behind the table. So I can see the hologram from here. You probably cannot on the screen now because we're seeing the preview. But as I move and I'm behind the table, it's hidden.
This is not systematically scanned the entire room and got all the geometry exactly. So are we looking at a trade-off with that?
Yes. Seeing as this is an entirely on-board process, so unlike, say, all the virtual reality headsets we've seen, this does not require a desktop computer. It's basically a mobile phone strapped to my face, just like the Tango. There is continuously a trade-off between speed and performance. So if you want to maintain the experience that everything is smooth, say at about 30 frames per second for all the content I'm seeing, it's going to start cutting corners. And it also goes down to the basically the capabilities of the sensors. How much granularity can they pick up, how much detail. So you'll see that they kind of tend to cut corners, they will ignore clutter on the tables, they're not very good with see-through surfaces. So for example, the glass walls over here, as you can see, they will simply not register. Because it all comes down to computer vision in this case, well, computer vision and the sensors. Just like we have seen with other AR stuff when it's through some sort of glass case or what have you, the cameras actually see the reflections, but unlike our brains, they do not know to discard them. So they don't really know what to do with them. The depth sensors, though, in this case, see straight through them. So that is both a good thing and a bad thing, depending on how you want to apply it. So I could place a hologram there, but it wouldn't necessarily see it as a wall. So let's see what we can do. Of course, it's not all just placing holograms around. Right off the bat, it's the idea that you can use the environment around you as your, well, computing environment. So if you could just transplant your everyday desktop use into the environment. So I can place a Word file over there, I can put my browser on my ceiling, make it a massive screen. Obviously, there are a lot of uses in entertainment. So the games on this thing are pretty good. They will use the environment. You can use the physics of the environment around you. So you can have a ball bounce on the table, bounce on the floor.
People have tried this kind of gesture-based and moving around kind of interfaces for computing before, and it doesn't ever really seem to take off. People are quite comfortable with a keyboard and a mouse or some kind of trackpad.
Indeed. Weirdly, this is probably one of the first examples where I've seen people just click with it. So it's only really got two gestures it recognizes, the click and the menu. But that is enough. It is enough for you to be able to do basic interactions such as drag stuff around, scroll around, select things in a way you normally might, pointing at something is a normal interaction, and it translates quite well. And it's also a reliability factor. So one of the reasons these things don't catch on is because they usually don't work. They have you're sitting there tapping things. This one is just registering and working quite well. The two gestures, for example, the bloom, I believe it's called, just works reliably every time. Same as the other main interaction, which is the click. So I'm not, well, there we go. Every time I click, we get an update of the mesh. You can see how it's reading the mesh there, the environment around it. Or if I want to get rid of windows, just point at what I want and remove. There we do have a bit of a problem. Yes, I can select things, and there are two gestures that work very reliably, but what we're missing is a cursor. Yes, I do have a cursor in the middle, like a crosshair in the middle of my view, but that means I'm relying on the direction of my head in order to basically look at something, center it in the middle of my screen, and then select it. This is a good and bad thing. There are various interaction methods to do this. Maybe I could point at something, but you'll see that pointing is actually not one of the most accurate things in the world. We have some other studies with other interfaces where you can see that people think they're pointing at something, but really they're pointing with their arm, they're pointing with their wrist, they're pointing with their finger. So getting a system that understands the intent of the user is pretty difficult. But gaze is pretty solid. We have a crosshair, we aim at what we want, we select it.
We're seeing a preview here, which is a camera on the front of the device, I'm assuming. Is your field of view a lot wider than that? Can you see more stuff? If you're looking at that cat, what can you see at the size of your eye?
That is a very good question. It's actually one of the things that, well, surprises most people when they put this on. The field of view is actually that narrow. Unlike pretty much every headset that exists right now, this is a proper heads-up display, meaning it's not like the Google glasses where I'd have my real vision and then a second little window up in the corner giving me a version of the real world. This is directly adding content to my normal vision. The problem is the area that it has to add this content is really very narrow. I think it's the equivalent of a 15-inch screen at normal distance. So really, my field of view of augmented content, and this sounds bad, but it's not that bad, is really just this angle over here.
But you
it's
can
really narrow.
see out the sides, can you?
Yes, I can see the normal. It's all perfectly clear. So I can see the cat now. It's in the center of my vision. But if I move my head ever so slightly, at this point, the cat is outside my augmented field of view. It is quite narrow. But this is a technology limitation that my understanding is has already been overcome. It's again a trade-off between cost and performance. These are developer kits after all. So they're already pretty pricey. If they were to have a proper field of view, probably the weight and power requirements would have made them quite unwieldy at the time. Yeah, the voice works very well, it's Cortana. So,
should we try and put it on the camera and let's see if this works?
Okay, so, oops.
So
I have to look out through one of the eyes, I guess.
oh yeah.
Oh, hold on, I see, yep, I see content.
Oh yeah.
There we are.
Okay.
Okay, so if
I
we...
hold that against there.
Yeah, aim one at the count, okay, and then we... And that, there's content.
Mm-hmm.
So there's
Is the
more
cat still there?
content. Yeah, let's... Oh, hold on, let me get rid of that. If we move forward...
Oh, there we go. Right, so
is.
it's quite interesting to see that
Okay.
line, isn't it? So if I put that on the cat's nose, for instance, and then what, click or something?
Yep, so whenever you can interact with something, the dot will turn into a circle.
Ah, okay, yeah.
Indeed, and also when it sees your fingers and it says, okay, you're ready to click, same thing.